Okay, so the question gives you these four functions, right? And then for all of these, we have to figure out that if it's one to one or onto. So if we get started on f, I should have done this before recording. It's fine. So if you have f here, this thing, you'll notice it's in all other ones. This thing with the arrow, what I think it means, I'm not too sure what it means because I never did one of these in class, but this N right here, that's where your domain comes from, and this thing is your codomain. So this thing is your input, that thing is your output. Yeah, your input in this case is just x, so I guess you could call that as x. And then your output is f of x. So f of x, I guess you could call y or f of x, whichever one you want to. But yeah, so now we need to know what the symbols mean, right? So this weird n thing, that basically means I had to memorize this, but I didn't yet. That means the natural numbers, right? So natural numbers, that's basically positive integers. So that's like 1, 2, 0, 7, 69, stuff like that, right? So that's natural numbers. And then this thing here, that's real numbers. So real numbers is like what? Negative 1/3, 0, 0.50, 2/10, stuff like that. So like weird numbers, I guess it can be negative and it can be fractions that you can simplify, but it can be negative, right? Okay, calm. Um, your I guess you only look at this thing if you're determining if it's onto or not. Because what's the definition of onto? The definition of onto that all y's have an x. Have an x, right? So all the y's have to be used up. So all your outputs must have an input. You cannot have an output that doesn't have an input, you know? So if we look at this, your domain only includes positive numbers. But this thing also includes negative numbers, right? Right? Yeah. Okay. So now if you substitute like let's say a positive number here, like x is 2, you have 1/2. Is 1/2 included here? Yes, it is. Can you ever get a negative number here? Yes, you can. If you make x equal to -2, you're gonna get 1/-2, which is -1/2. But -1/2 is not in the domain. It's in the codomain, that's why you got that, but it's not in the domain itself, you know? Since it's not in the domain itself, it's gonna be not onto because you're getting a negative value, but your domain doesn't include negative values. You get what I'm saying? It's kind of weird, but takes a while to get used to it, I think. The thing is, I did this question a lot, so I remember the answers kinda. But anyways, for this one, it's gonna be not onto them, right? Because you're getting something that's not included in the domain. Now, if you're determining if it's one to one or not, the way I think is you have to see if you can get the same value through different by inputting different numbers, right? So what's the definition of onto? It's just that x1, x2, y1, y2. X1 has to have y1, x2 has to have y2. Like x1 cannot have two outputs. So if you look at this, what you're basically doing right now is you're finding out x that gives you two different y's. Or you're finding an x, or you're finding a y that has two different x's. So you're trying to figure out if you have the same output if you input two different x's. So let's try it. You have f of x equals 1 of x. Can you insert any number that's a natural number, which is just positive integers that will give you the same thing as another integer? Like, let's see. f of 2, that's going to give you 1 over 2. What about f of 4? It's 1 over 4. F of 420, that's 1 over 420. So it's a bit hard to realize, but if you look at all this, then you're going to eventually realize that no matter what you put in, you cannot get the same y value, like ever. What x would you insert here that's going to give you the same y value? Because 1 over x is basically just x to the negative 1, right? If you insert any number on behalf of x, 1, that's 1 over negative 100, that's 100 to the negative 1. It's just no x will give you the same y. If no x gives you the same y, what does that mean? That means it's 1 to 1. There you go. I don't know if that made any sense, but it's fine. Next one is G. I should just copy it. iPad. Wow. Okay. Then erase. So you have that. Now remember how for the previous function f, I said that you only look at this part if you're determining if it's onto. This one is a bit weird. You might see this symbol here and you're gonna think, oh, cross product or whatever. But no. If you look at the function takes in two inputs. Function f of x only has one input, but function g of x has two. G of x takes in x and y. So there's two inputs. So you have to determine the domain for those two inputs. What numbers do those two inputs include? Those two inputs both come from natural numbers. That's why you see this thing here. That's not multiplication. That just means x comes from that group and then y comes from that group. And what's the natural number group? That's just 1, 2, 3, just positive integers, right? And your output is this. And according to the prompt, if I look back at it, according to the prompt, this weird Q plus thing is positive rational numbers only. So it's just positive rational numbers, right? So rational numbers, just weird fractional numbers. So I guess 3 over 7, 0.02. If you have rational numbers, you could have negative 3 over 7, negative 0.02. But since it's Q plus, it's just positive. So you're just going to have these, right? So let's see if it's onto first. You're inputting only integers here, and then you're trying to see if you can get a positive rational number out of it. So let's try it out. Let's say x is 1 and then y is 2. If x is 1 and y is 2, we have 1 over 2. The rational number is included. 1 over 2 is included in that. You cannot insert a negative x or y because natural numbers doesn't even include that. So your input only has to be restricted from 1 to greater. So if you do 1 to greater, can you get 0.02? I mean, sure. You could have x equals 2. You could have y equals 100. That's going to be 2 over 100, which is basically 0.02. So it does include all of them. Like, no matter what integer you put that's greater than 0, you are going to get an answer that's a part of the Q plus set. So, since all of the codomain is covered by the domain, it's onto. It's kind of similar to the other one where you're trying to get an output from something, but you don't know if it's the right thing. You know? Okay. Anyways, now we want to see if it's 1 to 1, right? Remember I said that 1 to 1 basically means that can you get the same y with two different x's? So if you have x over y, and let's say you want the input to be like 4. So that thing has to equal to 4. You can do that in a lot of ways, no? Like you could have like 8 over 2. You could have x equal 8, y equal 2. That's going to give you 4. You could have 24, x equals 24, y equals 6. That's going to give you 4. What is 4? 4 is your output. And then this is your input. So for the input of x equals 8 and y equals 2, you get 4. But for the input of x equals 24 and y equals 6, you also get 4. If you have two outputs, wait, no. If you have, oh man, ruined my whole flow. If you have two inputs giving you the same output, it's not 1-to-1, you know? So that's why we're just gonna say it's, is it 1-to-1? No, it's not 1-to-1. It's probably onto, not onto, not onto, 1-to-1. Yeah, so that's that one done. Oh, okay. Next one. Next one is this thing. Copy, paste. All right. So you have the function h of x. And now that weird thing we did for number 2 is gone. There's only one input and then one output, because h of x only has one, right? So let's see. So this weird c, that is just integers. That's not this q. I mean, if you flip the n, you can see that's helpful. But that's integer, so this includes -1, -100, 0, 1, 50, 1000, just whole numbers, right? But it can be negative. So the only difference between this and whatchamacallit, this n, is that n is only positive integers, and then z is all integers, included, negative, my bad, negative included, right? So this thing, not that you need to know n for this question, this thing, you're giving out any integer, you're seeing if your output gives you an integer that's included. So what you want this output to give you is that we just said it includes negative, right? So if your output cannot give you negative, it's not onto. Like x squared, there's no number you could put in here that's going to give you a negative number. The square of something is always positive. Like you could have x equals -1. -1 squared, that's just 1. You could have x equal 1. 1 squared is just 1. You could do this with x equals 50, x equals 4, x equals 12, x equals anything. The square of any number is never negative. So you're inserting negative number, output is never negative. But your codomain, remember, includes the negative number. So I guess if you go back to the umbrella example, you can think about it as like you can get a negative output, but there is no x that maps to it. So what do we call y's that have no x's? It's not onto. It's not onto. Now, we ignored this part, because who cares? We already figured out that's not onto. What happened to my... Did I run out of charge? No, it's fine. No, it's not. Okay, not onto, right? Now, we need to see if it's 1-to-1. So, remember how I said it includes negative numbers? What is wrong with this pencil? It includes negative numbers, right? Can you think of two numbers that gives you the same number? Like, let's say 49 is your output. 49 is 7 squared. So, if x is equal to 7, you get 49. But remember how negatives included? If x equals negative 7 squared also gives you 49. And it just goes back to this example where two different inputs give you the same output, meaning it's not one-to-one. Because you can have negative 6 squared, that's going to give you 36, but 6 squared also gives you 36. 36 and 36, you get two of the same, but you have different x's. So it's not one-to-one. So it's not onto, it's not one-to-one either. So this is the exact opposite of a bijection. It's neither. All right. So, whoa, didn't want to do that. So that's, oh, my bad. It is way too long. So that's that. I need to really learn the symbols. Why can't I minimize this? I would crop this part out, but who really cares? Like, actually. Next up, this R thingy. And then W of x is equal to x plus 1. I forgot the equal to sign there, I think. Yeah, there's it. So 3x plus 1. Alright, it's 3x plus 1, right? This R thing, remember we did this before, it's real numbers. So real numbers is going to be like negative 1/3, 0.50, 0, negative on a positive 3, 1/3, negative 0.50. It's basically all the weird numbers, as I like to say, like stuff, like everything is included, I guess. So we're looking at onto first. So we look at this. Okay, so this thing includes negatives. Can you get a negative number from this expression? W of x is equal to 3x plus 1. Can you get a negative out of it? Yes, you can. If x is equal to negative 2, 3, negative 2 plus 1, negative 6 plus 1, negative 5. Yeah? Okay, it includes negative. Can you get decimals? Let's make x equal to 1/2. So 3 times 1/2 plus 1. 3 divided by 2 is 1.5 plus 1, 2.5. You can get decimals. If you make this negative 1/2, you would have gotten negative 1.5 plus 1. That's negative 0.5. So you can get a negative decimal as well. You can get a negative anyways. If you had just 2 here, then you would have gotten 7. So no matter what you include here, you are bound to get whatever it is you're looking for. If you want a negative, it can give you a negative. If you want a positive, it gives you a positive. If you want a negative fraction, it gives you a negative fraction. Just a positive fraction. Decimal included. Everything you want, possibly, is included here. If the domain includes everything, codomain includes everything. I'm sorry about my handwriting, it's fine. Then that's onto. Because you can insert anything you want. Whoa. Where? Whoa. The worst video ever. But yeah, if you get stuff and you get stuff, it's onto. It's a horrible explanation. If you insert stuff in here that's negative, positive, fraction, negative fraction, decimals, and you get negative fraction, decimal, positive, negative, whatever you want, it's onto. Right, now we'll look at if it's 1 to 1 or not. W of x is equal to 3x plus 1. Is it 1 to 1? Can you insert two of the same numbers here that give you the same output? Let's try. X is equal to 2. 3, 2 plus 1, 6 plus 1 is 7. Okay, maybe a negative 2 would give us the same answer. 3 times negative 2 plus 1, that's negative 6 plus 1. Oh, that's negative 5. Never mind. What about the reciprocal of 2? What if x equals half? 3, 1/2 plus 1. 1.5 plus, oh, that's 2.5. Never mind. What about negative that? What will happen then? Plus 1. Oh, that's 0.5. Interesting. You can never find two x values that give you the same y here. Like, no matter how much you try, you cannot name any x value that gives you the same y value. Since that's not possible, so all y's have a distinct x, that's 1 to 1. And if something is onto and 1 to 1, we call that a bijection. There you go. So this one is not onto and not 1 to 1. This one is onto and onto, not 1 to 1. This one is not onto 1 to 1. This one is a bijection because it's 1 to 1 and onto. Yeah? Cool. That was a very bad, horrible explanation, but it is what it is.